Hello GED students, it's GED question of the daytime, and this problem might look to you like something that might come up on the English or science or the social studies test, but this is actually a math question. Yes, it's words. Let's take a look. It says, which of the following statements is always true of perpendicular lines? So I'm talking about perpendicular lines. I'll just remind you that perpendicular lines are lines that intersect, and intersect is just the fancy word for cross. So lines that intersect or cross at a perfect right angle, 90-degree angle. 90 degrees, like hopefully the corners of your house. So we've been talking about that a little bit. Let's look at these statements. It says, A, perpendicular lines have the same y-intercept. B, perpendicular lines have the same slope. C, perpendicular lines have y-intercepts that are opposite reciprocals. Or D, perpendicular lines have slopes that are opposite reciprocals. Well, I hear a lot of graphing language here. We're talking about y-intercepts. We're talking about slopes, y-intercepts, slopes. We're obviously talking about what perpendicular lines are like on a graph. In order to explore that, I really do want to just check out a graph. So let's go ahead, see what we can see if we look at some perpendicular lines on a graph. So we will just pretend here that we have an XY plane. So remember, your x-axis is your horizontal axis and your y-axis is your vertical axis. Okay, and I'm going to draw a line here, and it's already messy. So got a line going on, and now what I want to do is get a line that is perpendicular. And I'm kind of cheating because I know this concept already, but I will show you just really quickly. So you are just going to have to believe me right now that this is perpendicular based on the visual. But yeah, I think it looks pretty perpendicular here. You can see we're crossing at a 90-degree angle regardless of where at the crossing I look. Those two lines create 4 90-degree angles between them, so they're obviously perpendicular. So now these particular ones that I created do have the same y-intercept. You can see that these two lines do cross at the same y-intercepts, but they didn't have to. I could have easily just taken this same line that I drew and put it like here, for example. And then these two lines would not have the same y-intercept at all. In fact, here, this particular line would cross y down here, and that would cross y down there. Okay, so I think that I can rule out the fact, one of the ideas here, that they have the same y-intercept. So if I maybe went too fast for you, I would just remind you that a y-intercept is where our lines cross the y-axis, So obviously, like, these two lines are perpendicular, and these two lines have different y-intercepts. And in another one, they had the same y-intercept. So I can see really that there's no relationship between the y-intercept. They could be different, they could be the same. I could draw these perpendicular lines anywhere on the graph. So then the relationship must be between the slopes. When I looked at my selections, they were all either about the y-intercepts or about the slopes. Let's check out the slopes of these perpendicular lines. So I'm going to start with the original two that I was looking at. Remember how to find slopes on a graph. The first thing that I want to point out to you is that slopes are either positive or negative. They're either positive or negative. And how can you tell if a slope is positive or negative? Well, sweep your eyes across the graph going from left to right and look if your line appears to be going down or going up. So let's look. I'll call this line 1 right here. So take a look at this graph. As I go from left to right along this line, I am definitely going down. So that particular line 1, has a negative slope. Now look at the line that we looked at that was perpendicular to line 1. So I'll call it line 2, this guy right here. You can see that if I go from left to right along this line, I'm definitely moving upwards. And so that particular line has a positive slope. So one thing I notice about perpendicular lines is that they have opposite signs. So let's write that down. Perpendicular lines have opposite slopes. That's one thing I noticed. Now let's look, it's not just the number, opposite sign, sorry. It's not just the number, oh my goodness, I'm messing up English. Let me say it's not just the sign of the number that we care about. We also care about the number itself. So remember, when you're looking at a graph, the easiest way to think about slope is to count the rise, how much your line is rising from one point to the next, over the run, how much your line is running from one point to the next. And slope is all over the GED, one of their favorite topics. So if that's the first time you've ever heard rise over run, I suggest you go back and do some thorough research of the concept of slope. But I'm going to do a rise over run of this line. So again, I'm looking at line 2. Anytime you're looking at slope, you're going to go from one point to the next. Slope is a movement. And so I must find out how much I am rising. I'm rising 1, 2. And how much I am running. I am running 1. So in this one, line 2, I have a positive 2 over 1 slope. Now let's take a look at my line 1. My line 1, on the other hand, when I talk about rise over run, first of all, we already know this, but you can see that I'm not even rising at all. I'm really falling. I'm going down 1, and then I'm moving over 2. A rise of negative, which we already knew, 1 over 2 means that I have a negative 1/2 slope. Now let's compare the slopes of these lines. We already saw that they had different signs, but now what I want you to notice is it's like these two fractions are flipped. One has a 1 on the top and a 2 on the bottom, and number 2 has a 2 on the top and a 1 on the bottom. And I see that the fractions were flipped upside down on their head. This is a math concept. A flip of a fraction is known as its reciprocal. And so what I see here is that perpendicular lines are opposites in 2 ways. They're opposites in 2 ways. At least their slopes are. Their slopes have the opposite sign, and the fraction of rise over run has been flipped on its head. The run has become the rise, and the rise has become the run. Okay, therefore, now let's go back to our problem here and check it out. Okay, it said which of the following statements is always true of perpendicular lines? Well, we just figured it out. Perpendicular lines have slopes. It's a relationship of slope that are opposites. And what do I mean by opposites? I mean different signs. Reciprocals. And what do I mean by reciprocal? You flip the fraction on its head. This you should know. You should have this fact memorized, that perpendicular lines have slopes that are opposite reciprocals. We're going to be looking at 2 more problems in the near future, maybe 3, where I'm going to use this concept to figure out all kinds of typical GED math problems. Great. If you have any questions about this or any other GED math topic, be sure to drop it in the comments, and I'll do my very best to answer it.